Hi friends, if you are searching an MEP job, this video for you. From our nation, a lot of people they are traveling to Gulf countries for searching MEP jobs. MEP means HVAC, plumbing, and firefighting. Electrical, I don't know really. I was a construction manager for Gulf countries. I worked in many projects, including this stadium projects and metro projects and airport projects and all. I faced a lot of interviews. I failed multiple times and sometimes I passed. And I will share you those interview question and answers. They are commonly asking. This will help you if you are searching a job in Gulf countries. So not only sharing the question and answer, I will share you the system how it is working. For example, if you are a new person in MEP, I will share you those experience also so that you can implement by yourself and you yourself will develop. This is what I mean. Okay, so we will start from where we will start. HVAC, yes, HVAC from where we will start. HVAC is a huge subject basically. HVAC, there is two things. There is water side and there is air side. What is water side and what is air side? Air side means, for example, from your fan coil unit or FCU or AHU, the air is passing through the duct and it is reaching through the grills and diffusers to this final destination. And this is air side. And water side, your chiller, your cooling tower, and your pumping station, chill water pump room, and chill water pipeline networks, heat exchangers. This all coming in the water side, basically. So this is the concept. Basically. There is chill water system is very simple. Air side also is very simple. Simply understand the logic. The thing is that how this cooled chilled water is created, how our refrigerator is working, almost a simple, same philosophy, same philosophy. For example, our refrigerator, there is a condenser is outside. There is some coils are there, small coils. But for heavy cooling system, this is not possible. There is a tower. There is a cooling tower is there. You may see there is some tower building is there. Some water is forcing, and through the pipeline with the water. This with the water in the pipeline, it is getting cold again and again. So it is circulating to the up to the chiller, and this chiller and this cooling tower, everything it is interconnected, but mostly there is a heat exchangers because the chiller there is a chemical whatever it is in the closed circuit line, it is circulating from the tower or for example discharge line, both are communicating with the heat exchangers. This is the concept we need to understand. For example, chiller. How to define a chiller? This is practically a site engineer or construction manager, they will not do. We will take the cooling load calculation. Based on that, the chiller manufacturer or supplier, they will decide which type of chiller, and there is a proper material submittal is there, and they will decide whether which type of chiller is there, what is the capacity, everything. And from the chiller, the concept is very simple. A condenser is there. Condenser unit, that is a cooling tower, and there is a chiller. For example, you can say the fridge compressor example, and there is an evaporator. Evaporator is not directly evaporating; it is evaporating through heat exchangers, and it is that cold heat exchanger means it's a cold water again passing to the pipelines. For circulating that third stage, there is a pumping room, pumping system is there. And there is a certain velocity. It is not passing in a high velocity, high speed. No. For heat transfer and heat exchanger, there is a certain temperature, certain velocity is there defined for heat transfers. I really forget what is the velocity exactly because I worked before. No, you can check what is the velocity is there. You can comment in the comment section also. This question they will ask you. What is the velocity, normal velocity? It depends upon pipe diameter. The velocity will vary a little bit, but there is a standard velocity is there, of course. And for buildings, many of the Gulf countries they will not keep a chill water plant room by their own. There is, for example, for us, there is a water supply system is coming from a government or something like that. There is a chilled water supply. Some companies they are supplying through networks. For example, multiple buildings, they will keep one tower building for chilled water. From there, it will circulate to the multiple buildings. So we don't want to keep chiller and other very difficult jobs and all. So what is our requirement? What is our how many liter per second we require to inform them? They will deliver that much quantity regularly. This is for sort of like commercial building and such kind of projects they will deliver. But for airports and such kind of heavy projects, they will not trust on this kind of third party people for air conditioned chill water supply and all, because sometimes they shut down or something damage, the entire airport will be hot, all the people will be evacuated. So that's the problem. So they have multiple standby facilities and all. I will come back to you on that. And I will tell you, for example, one metro station. Metro station is they are taking from outside. To be frank, there is one chill water tower is there, and it is distributing to multiple metro stations. And when we getting the main pipeline to the metro station, there is a pumping station. From the heat exchanger only we can take this cooled air, and there is a pumping station is there. And in the pumping station, normally using VFD facility, VFD technology, variable frequency drive. What is VFD technology? Also, I will explain to you. For example, maybe in the interview they will ask you what is three-way valve and what is two-way valve. I will come back to you on that. The pumping station, that is, there is a multiple number of maybe one running pump and one is standby pump. This pump will circulate the chilled water to the line and it is returning back. To the line means your FCU to your AHUs. It will circulate the chilled waters. And one is supplying, and from other side it is returning back. Again supplying, return back. And where it is cooling, through this heat exchangers, it is getting cooled again and again and again and again. So this circulation is always there. Do you think that it is a constant flow? No, never. Because some of your AHU or FCU is shut down. There is a building management system is there. For example, if you shut down the FCU or AHU, the signal will reach the building management system, and the pump rotation, the speed, RPM, it will reduce or increase, whatever it is, through the variable frequency drive. Variable frequency drive is nothing. It is a simple electrical device. It will, the heads. Normally 50 hertz you may hear. This hertz will change, then the RPM will change, not decreasing the voltage. For understanding, for example, to reduce the motor speed, we will reduce the voltage. No, don't say like that. It is just changing the flux. But we can. I don't know really. It is 50 hertz, not flux, hertz. Hertz will change, so your RPM will change. This is the concept. This is mostly using in air side also for firefighting, exhaust fan and all. I will come to that. Don't want to mix everything. So chilled water concept you should understand first. But in early stage there was no, what do we call variable frequency drive technology. Like in 1890s and all. Was there, but it was not using basically. That time the chilled water flow was constant speed. For example, if you shut down, for example, you have 20 AHUs or 30 AHUs at site. Some of your AHU is already shut down, and it is some area there is no occupancy is there. It is shut down. But again, the chilled water pump will run in the constant speed, constant velocity, everything same. Then how it was handling? For example, chilled water, the AHU is shut down. There is a three-way valve technology is there. The valve will bypass again to the main line. So the full air water it is circulating again and again and again. But the technology changed, everything is changed, variable frequency drive came, then the two-way valve technology came. So there is no three-way valve technology. The two-way valve technology is key. Two-way valve is more advanced. Because for example, one AHU shutdown, the supply line, they will, the isolation valve is there, automatic isolation valve is there, there is a actuator is there, it will close the valve. So in that condition, the building management system will give the information to the variable frequency drive, and automatically step by step this RPM will reduce, and water flow will control. This is the technology, simple technology is used. This two-way valve or three-way valve, which was previously using, no, this is standard structure basically for the AHUs and FCU, whatever it is. If there is AHU, there is two types of AHU is there. If somebody asks you, there is a floor mounted AHUs are there. It is sitting on the plinth. It is a big box, you can see. AHU actually what is doing, the chilled water, it is passing through a coil and the air is passing, then the air is getting cold. That air will supply to multiple locations. That is a very simple philosophy. And for selection of AHUs and FCUs, there is, of course, there is a manufacturer is there. They will help you. For example, you will take the cooling load calculation, give it to your people. They will design the selection of AHU, FCU. They will do it. You should very clearly understand there is a valve package, not a valve package. No, valve, VAL, valve, the valves. Valve package for AHUs and FCUs. This is the repeated question I face in Gulf countries. Valve packages. Make a sketch for the valve package. And there is second question is that what is three-way valve and what is two-way valve? And you clear, I think. Three-way valve means it is a old technology. If there is no variable frequency drive, you will use three-way valve, because once you switch off the AHU, the water will circulate back to this main network. So the water velocity, it is running in a constant velocity, the water. The two-way valve system, it is the latest technology which is working through variable frequency drive. And once you shut down the FC or AHU, it will shut down your isolation valve, and the full water supply will stop to that particular device, and this signal will reach to this variable frequency drive through building management system. This is what we need to understand. And for the pump installation, this all the things, practically you need to see at site. If I explain to you, I don't know how much it will be possible. How you fixing the pump. There is a plinth is there. What is the plinth height? 150 mm. There is so many standards are there. There is a plinth means there is a concrete platform. There you will fix the pumps. In the plinth, what is the, how you connect this outside the pipeline to this pumps. Through flexible connector, something like that. There is a flexible connector is there. Of course, there is a vibration is there. So those things. And there is one common question in chilled water. They will ask you, how you will connect, how you will take that, drainage from the FCU or AHU. If you connect direct to pipeline, the water will not come out through that pipe. If there is a water condensation water is there, again it will not come out. Reason is that there is a static pressure is there in the AHUs and FCUs. So there will be once you take the pipe, there is a trap like that. You trap and you take the drainage pipes. This common question they will ask you. And the three-way valve, two-way valve, and both AHUs and FCU valve package you must learn. This is very, very important. So normally which kind of pipes they are using for chilled water? It's a mild steel, like steel pipes. carbon steel, high carbon steel, something, not steel, not like stainless steel. No, it is not stainless steel pipes. It is, and you will think that it may be corroded. Corrosion is there, of course. So there will not be corrosion. And there is a chemicals is there in the chill water lines. So there will not be chance for corrosion. There is so many things are there for anti-corrosion chemicals are there in the chill water lines. So it will not be corroded. And how this chill water pipe is insulation, and what is the material is using for insulation? There is a rack wool insulation is there, glass wool insulation is there, and there is rubberized information also is rubberized insulation also is there. So normally is using, you can say that it is a rack wool insulation or wool. Otherwise glass wool insulation. 50 mm, 100 mm, it depends upon the temperature. The insulation thickness also is varying. So this is what you need to explain to them. So it depends. For example, 100 mm pipes, normally 75 mm. Internal and outside piping insulation thickness is different. For example, indoor and outdoor, different. Plant room inside again thickness is more. For example, if it is a space where the people are all the cooling area, there is no need for too much thickness of insulation. There is a calculation is there how to select the insulation. This is that I will make it in a separate class how you can calculate this one. And this is a very simple philosophy. You may understand what is chilled water system and how, for example, how high-rise building, how you will take the chilled water to the vertical levels. There is through shaft is there, vertical shafts are there. There is a wall clamps are there. There is a brackets again. It is clamping to the wall and we will take it up. And how these chilled water pipes are joining. You can say that this is all questions. The higher diameter pipe like 100 mm, like 150 mm, this kind of 75 mm above, it's welded joint, and 50 mm down normally is threaded joints. There is a threaded joints are there. 50 mm, 40 mm pipelines, 1 inch pipelines are all. 1 inch is normally connecting to the fan coil units, small fan coil units and all. 1 inch pipelines. This is all threaded joints. No need for a welding joints and all. This is depends upon some standards are there. So above 3 inch it is welded joint, and below 3 inch is normally threaded joints using. And the insulation part you see already. Which are the brands you are using for insulation? They maybe they will ask you. There is many companies are there like Arma Flux, KF Flux, such kind of so many insulation companies are there. They are manufacturers of this kind of installations and all. And the chilled water pumps, which are the brand you used? You can say that there is multiple brand is there. For example, Willow. In the Gulf countries, Willow is the big brand. And there is, Grand Force. And such kind of many brands are there for chilled water pumps. And VFD, and I don't remember which brand is there, variable frequency. That's the electrical part. Basically, I really not remember. And the chilled water pipes, like steel pipes, which brand you are using? Like Tata Steel and Jindal Steel. It is they are very familiar in Gulf countries. In India, it is very common, but in Gulf countries, very familiar. This Tata Steels, Tata pipes, Jindal pipes, mostly using their Gulf countries. In the spec, it is really matching. And seamless pipe and normal piping. Seamless pipe means, for example, the sheet which is bending and making a pipe, it is normal pipes. Seamless pipe, it is direct pipe it is creating. So when you are seamless pipe means in the inside, if you put your finger around, there will be there is no joint. You can see that. Maybe you can experience. Seamless pipe normally using in chilled water system. There is no joints because in high pressure there is do not want to blast. That's the thing. The sheet it is joining like that, and it's coming in a round shape. That is normal pipe. Seamless pipe, it is directly pipe. So this you should understand. You should have a knowledge about that. And isolation valve, there is so many brands are there. I really forget. You should study which are the best brand using isolation valves. There is some fittings you should understand. What is wise trainers, isolation valve, drain control. Sorry, double regulating valves. That kind of valves you should understand. Why we're using double regulating valves. Double regulating valves is using for all valve packages in the supply line. There is a return line. In the return line there is a double regulating valve. Very important question: why you are fixing the double regulating valve in the discharge line? Why not in the supply line? Question is very simple, but the answer is that when your supply line, there is supply line, if you put regulation valve, regulating valve, double regulating valve, the coil will be empty. The cooling coil will be empty. So if you fix the DRV in the discharge line, the cooling line will be fully loaded. DRV and this two-way valve or one-way, three-way valve, whatever it is, it will be in the mainly controlled in the return line. If, for example, the two-way valve we fix in the return line. Return line means the coil is fully loaded. When we switch on the AHU, the first cooled air will transfer to the destination. That's the main thing. So this is the basic concept we need to understand about the chilled water supply line system. And the pipe diameter, everything will vary. Depends upon the number of AHUs, number of FCUs, and cooling load systems. Everything consider on the pipe diameter. Pipe diameter calculation, I will make it for you, no problem. How to define a pipe size and what is the how many liters of cold chilled water air is required. This all I will make a calculation section. The second part is that our air side. Air side is very important basically. Air side normally considering how all about cooling load calculation. Cooling load calculation, there is a HAP cooling load calculation I made in this video, in this channel itself, maybe 2 years before. Yeah, 3 years before, I don't remember basically. The cooling load calculation, it is very good. You should understand that one. Based on the cooling load calculation, all the AHUs and FCUs designing. And there is a duct. What are the types of ducts are there? Duct, air ducts. Duct is very simple. The cold air transferring media. Maybe this is round duct, maybe square duct, yeah, rectangular duct, or there is another. Normally, many 99% is using GA sheet duct, sheet fabricated ducts are using. But in some cases, for easy way like that, there is there is some ready-made duct also is there. That is not GI, some like plastic type material. I forget really. There is a specific name is there. You can comment to somebody this. That kind of duct, prefabricated ducts are there. So this is also some places using, but all the commercial buildings and long lasting is of course GA. And GA duct, what kind of insulation using? GA duct normally glass wool, rack wool, and this rubber type of Armaflex and all it is using. And again, for kitchen duct, if you can use GA sheet, GA duct, no. For the kitchen side, MS duct and stainless steel duct normally using. Normally, mostly stainless steel duct. Stainless steel is very expensive. There's because in this kitchen there is called a tar. So, such kind of things are there. There's a black things. So there is a trap also is there for in the kitchen duct, kitchen exhaust duct. There is a tar trap also they are fixing in some locations. So this kind of liquid items, it will come there and you can remove it and clean it and refix like that. So this is the kitchen duct system, and for some toilet exhaust and all, the round duct is using round duct. That is again GA duct is using GA round shape. It is fabricated, which is coming from the factories. So we need to just to fabricate small connection fabrication only. We need to do at site. We need to install it. And there is so many types of grills and diffusers are there that you have to understand what is the grills, what is the diffusers, and what is drum jet diffusers. Drum jet diffuser you may see in the airports if you go, and some major metro stations. This open area is very big. In the side wall or somewhere, there's a round shape jet type, the round, so many rounds. This high velocity air, it will push to the long distance. This kind of diffuser is called a drum jet diffusers. And there is grills, you can see grills, small grills. There is a vertical ceiling type diffusers is there. There is a long type is there, a rectangular type is there. Rectangular is a square type. 600 by 600, 300 by 300. This is all designing depends upon the airflow. And there is, not only airflow, this, sound level, this less than 20 dB sound should be there, less than 20 dB. That is occupied area decibels sound system. Less than, whenever we are designing the grills and diffusers, we will choose less than 20. If it is like a factory, or if it is like a plant room or something like that, you can go for up to 35, 50, no problem. The sound is more, the air flowing, there is of course there will be a sound. So we need to reduce the sound, and for reducing the sounds, we cannot use direct connection the duct to this grills. There is a plenum box. Plenum box, for example, from the duct velocity is very high. It is in the plenum, when it is reaching, it will be a the velocity will reduce, and the flow is same, but the velocity will reduce. The smooth flow we can create. That's the reason we are using the plenum boxes. Through the to the plenum boxes only we will connect all these grills and diffusers mostly. And exhaust type sometimes we will directly install sometimes. But for supply mostly plenum box. Supply, of course, plenum box is required. So you will you need to search in the Google also what is plenum box. Plenum box. Okay. So this is all. And the plenum box to the main duct, how the duct is connecting? Flexible duct. You will connect with the flexible duct. What is the diameter of that flexible duct? 150 mm, 200 mm, such kind of flexible duct. Flexible duct, what is that? It is like there is a spring inside, and there is some you can increase or decrease, some such kind of thing is there. It is a flexible, inside will be some sometimes of corrugated type, I think. Yes. So this is the and how you connect flexible duct with with the plenum box. There's a plenum box. There is a mouth. Is there a mouth to this flexible duct? You will connect like that, and there is a Jubilee clamps we will fix, and there will be taping system. Aluminum tapes and all. There is we will fix through aluminum tape, so it will be very comfortable. And what is the maximum flexible duct you can use? For example, your plenum box is there 5 meter apart, your main duct is there. Can you do flexible duct? No, 1.5 meter maximum. From plenum box 1.5 meter maximum your main duct. If it is more than that, you should bring a duct like DA duct. You should bring from there the flexible duct you need to connect. So this is all the thing you should clear about this one. And of course, there is a return line. There is a thermostat is there, the controlling system, everything through thermostats. This basic idea I think you got about HVAC. And any more clarification about HVAC, of course, you can comment in the comment section. I will work on it surely. And I think the video is too long. The next video we will continue for the water supply system, and again another video for chilled water system. So water supply, drainage, and water supply is both things are there. So both we will do it one by one. So if you are searching a job in the Gulf countries, best wishes from my side. Any doubts is there, you can comment on me and I will answer to you. Thank you so much for watching this video. Thank you. Bye bye.